Good day, I am Mikhail C., ID 123, and I'll be teaching CALENG1, Quiz 2, specifically the topic of higher order derivatives.
So before anything else, let us first explain what a higher order derivative is. So a higher order derivative is basically a derivative of a derivative, which means that y prime, which is a derivative of y, you take the derivative of that with respect to x, which means if you expand this, so to a quick example, we have y equals 2x squared. So we have y prime equals to 4x, which means that the second order derivative, which is also equal to y double prime, is equal to 4. And this is how we get double or higher order derivatives. So if it's the third derivative, then we get the derivative of this, which will now be 0. So some common notations of higher order derivatives include the following. So for third order derivative, it would be y triple prime, or it also be f triple prime of x, or the common notation, which is this notation, which is the third derivative of y with respect to x. Similarly, for orders higher than 3, we use this notation, where n denotes the nth order derivative it is. So now let's move on over to our practice problem. So our first, we must find the sixth derivative of this equation. Y equals 1 over 9 x raised to 6 plus 5 x raised to 5 minus 2x cubed minus 3/7 x plus 12. So first derivative of this, we must use general power formula for each term. Since it's addition and subtraction only, we can just do the general power formula in each term. So for this, 6 times 1 over 9 is 6 over 9, which is also equivalent to 2/3 times x raised to 6 minus 1, which is 5, plus 5 times 5, 25, times x raised to 5 minus 1, 4, minus 3 times 2, 6, times x raised to 3 minus 1, x squared, minus 3 over 7 times 1, which is 3 over 7 times x raised to 1 minus 1, 0. And derivative of a constant is 0, so that's our first derivative. Since we need to find the sixth derivative, well, let's do this 5 more times. So y double prime, second order is this one, so 5 times 2/3 is 10 over 3, x raised to 4, plus 4 times 25, 100, x raised to 3, minus 12x, minus 0, since 3/7 is a constant. Now our third derivative, let's also write the fourth one and the fifth one and the sixth one, just so we're prepared for later on. So third derivative, 4 times 10 is 10 over 3 is 40 over 3. Then x raised to 4 minus 1, x cubed, plus 100 times 3, which is 300, x squared, minus 12. And for this one is 40 over 3 times 3 is 40 x squared plus 2 times 300, 600x, constant 0. Next we have this 2 times 40 is 80x plus 600. And lastly, 6 derivative is 80 times x raised to 1 minus 1, 0, which is also 1. And derivative of 600 is 0. So our 6th derivative is 80. Another way to solve this is that by looking at this equation and by observing from here, we can tell that since we're looking for the 6th derivative, only the first term, only one term will appear in our final answer, which is also related to the first term of the equation. So what we must do there is that we treat everything else as 0, since it will eventually end as a constant by the 5th derivative. And as for the 6th derivative, we can just do 1 over 9 times 6 factorial, since we know that at each derivative 1 power of x is divided from it, while the exponent of x is multiplied to the constant. So 6 factorial is equal to 720. 1 over 9 times 720 is equal to 80. It's just a shortcut which we may use sometimes, but recommendedly for long quizzes we follow the long format so that we have a complete solution. Now for second problem, we have y equals 6 over x minus 1, and we have to find the third derivative of the said equation. So to get the first derivative, x minus 1 squared. So for this one, we can first alter the equation for it to look like this. So y equals to 6 times x minus 1 raised to negative 2. That way we can just have our first derivative be equal to 6 times the use general power formula over here, leading to this answer. So negative 2 times x minus 1 raised to negative 2 minus 1, which is times x minus 1 raised to negative 3. Meanwhile, so finalize this, negative 12 times x minus 1 raised to negative 3. So for our second derivative, we follow through this, negative 12 times negative 3 times x minus 1 raised to negative 3 minus 1, and finalize it here, 36 times x minus 1 raised to negative 4. Meanwhile, for our third derivative, same process, 36 times negative 4 times x minus 1 raised to negative 4 minus 1, general power formula, which is now equal to 144, negative 144 times x minus 1 raised to negative 5. Actually, we must expand this, but since we know that the derivative of x minus 1 is just 1, then in that case it's just always 1. But normally, even if we use the general power, well, we cannot use the general power formula here, since we must take the derivative of x minus 1 and multiply it as well. But the derivative of x minus 1 is just, well, equal to 1. So yeah, each time. So yeah, we must not forget that in our solution. So it's equal to 1. So same final answer. This is still the final answer, or if you want it in the same format as earlier, negative 144 over x minus 1 raised to negative 5. Yeah. Let's just add times on here to make it clearer. Okay. So now let's move on to our final problem, which is finding the 100th derivative of f of x equals the cosine of x. So in here, definitely we won't be able to do 100 derivatives in a 1 hour 30-minute exam, but since we're tackling trigonometric functions over here, let us try to find a pattern that will occur as we find the derivative of this function. So y equals cosine of x. So if we get the first derivative of this, we will get negative sine of x. Let me just cross verify that. Yep. And if we get the second derivative of this, we'll get negative cosine of x, since the derivative of sine x is cosine x. But since we have a negative 1, that's constant, we multiply to cosine x, negative cosine x. Meanwhile, the third derivative is negative 1 times the derivative of negative of cosine x, which is equal to negative sine x. So negative 1 times this is sine x, which if we bring forth to the fourth derivative, this one also is also done by others as a notation. So equal to cosine x. So from there, it will be a repeat again. So the fifth is going to be, so the fifth derivative is going to be negative sine x, then sixth, seventh, eighth, so on and so forth. And we know that 100 is a multiple of 4, therefore 100 will fall under this row, meaning that the 100th derivative of the function, so y100 is equal to this cosine x.
Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Mkel from Syntax, paving your way to excellence.